to discuss is instructions and instruction sequencing part number 3, where previously we discussed some of the long session like what is instruction sequencing and what are the fundamentals of instruction, and we discussed about the finally branching or straight line sequencing and why branching is so important. Until now some of the computers and everything based on the concept of branching in the computer organization. So let's continue the session. Today is a small session where we have these are things definitely helpful for write and solve the GATE or any government or government exams like that, competitive exams in future also. Let's go through here. Today the topic we are going to continue to learn, definitely to have to learn about the conditional codes, some of the very basic in the computer organization, and then indirection and pointers, at last additional modes. So we'll see it step by step on here. First one is the conditional mode, where conditional codes. Here the processor keep the track of information about the result of various operations for use by subsequent conditional branch instructions. This is accomplished by recording the required information in individual bits, often called condition code flags. These flags are usually grouped together in a special processor register called condition code register or status register. So there are four. They want to convey here. They want four things. Four individual code blocks is there. These will be used in the computer organization whenever needed. So these commonly used flags are called. First one is the N negative. Next one is Z0. The next one is we shortly say overflow, and carry it will be denoted by C the symbol. So first one negative, it's set to 1 if the result is negative. Otherwise it clear to 0 by default. Then Z0 set to 1 if the result is 0. Otherwise clear to 0. Then V overflow set to 1 if the arithmetic overflow occurs. Otherwise it will be clear to 0. At last C carry set to 1 if a carry out results from the operation, or otherwise clear to 0. Clear to 0 like that. Clear to 0. Yes. Then we want to say some of the information things keep in mind, sir. That is, the N and Z flags are affected by instructions that transfer data such as move, load or store like that. The instruction branch greater than 0 test one or more conditional codes. In some computers, conditional code flags are affected automatically by instructions that perform arithmetic or logic operation. These are things you have to keep in mind, sir. Then go very important topic here, indirection and pointers. So what do you know indirection pointers? Generally you know the register or memory location that contains the address of an operand is called a pointer. This keep in mind, sir. Similar to C language, indirection is the ability to reference something using name, reference or container instead of the value itself. The most common form of indirection is the act of manipulating of a value through its memory address. For example, accessing a variable through the use of a pointer. That is a point like that. That is the indirection here. And also indirection and use of pointers are very important and powerful concept in the program. So assume that, let's say the small example here, indirection and pointers, you can clearly understand the real time example. For example, I have a value called here. I have x, the number x is the variable where the x original address is 200, but it be in the y. If you want the x, I want to get the value through the y only, y variable only. So I want to get the x value of 200. So what will happen? It will, I want to, if whenever apply indirect, it go via y only. The y will have a value of 100, and again the 100 value will denote to the original value of x, that is 200. So like that you can go and indirectly get the answer. So many of the modern computers using the indirection pointers only. Then we go to the small task, that is a program task we already discussed in the previous class. That is the using a loop to add n numbers. Here move n comma r1, clear r0. We already discussed here branch applying. For this example we are going to apply the indirection pointer. How will you efficiently execute the program very fast? So you will see here. So before seeing this code, we have see here we have use of indirect address in the code like this. Move n1 comma r1, that's r1 value. Move to n, then move number hash number 1 comma r2 initialization. These are, and clear r0 by default. R0 will be 0 only. Sir, r0 only 0 only. Then add r2 comma r0. Then hash 4, that is immediate mode, comma r2. Then decrement r1, branch greater than 0 loop. And finally move r0 comma some, where loop will repeat it till satisfy the condition. So we'll see the explanation, then I'll give the real time example. Here we are going to see the solution for the above diagram. So this diagram, what you have to understand is, if you want to indirect access can be access successive numbers in the list, resulting in the program like that. Here register R2 is used as a pointer to the numbers in the list, and the operands are accessed indirectly through the R2, and also the initialization section of the program load the counter value n from the memory location capital N into R1 register and uses the immediate addressing mode to place the address value num1, which is the address of the first number in the list, into R2. For example, you can say add R2, 0. Why the parentheses we are giving it? Because these are command the category indirect address. The second add instruction, add 4 to the contents of the pointer to R2, so that it will be contain the address value in num to capital letter when the above instruction is executed in the second pass through the loop. So here, we go through the loop here. Assume that we are going to execute the operation. The n value, that is R1 value, n value 5, like n value are same. So assume that with the R1 value 5. So 5 means what? We can execute the addition of two numbers 5 times only. So one time completed, the decrement operator applied, so it become 4 times. That is branch greater than again 0. So again it will execute the R1 value become decremented 3, and so until reach 0, it will come and work with the loop here. So assume that we are going to add the two numbers called 2 plus 3, first operation. So here what is there? We have R2 value, R2 is there, where R2 will move to the number 1. So if you want to addition of two numbers, we need a support of two registers here, that is add R2, R0. So assume that R0 value initially 0, R2 value we don't know, but we are going to finalize the R2 value become 2. So what will happen? R0 plus R2, already R0 is 0, so R2 value is 2, so 0 plus 2, 2. The final answer in the R2, that is additional value, final updated value of R2 is 2, 0 plus 2, 2. Then it will add to the immediate mode. You assume that the immediate value mode value is 4. So 2 plus 4, 6. So finally the addition operation have stored the value 6 in the sum, where it finally moved to the R0 register. So this is the execution of first operation. So similarly, you assume that again we are going to apply. I am saying 2 because enough. If you know 2, again repeated process only. So branch, so till reaches 0 or like that, it will decrement. Assume that n value 5. So one operation completed, you got the answer of 6. Now again we go to the loop. It will now it will allow the R1 value become 4. So it will allow again 4 times the operation. Assume that again the R2 value will move to the num1, where R2 value, what is the value we got? 6 now. So assume that we have R2 value 6, here R0 value again 0. So what will happen? Add R2, 0. So 0 plus 6, 6 will be there. The R2's final updated value is 6. Then it add with the immediate mode 4, where I assume that the immediate mode value is 4. So 6 plus 4, 10. Finally, the sum of two registers, the 10 two variables, 10 will be stored in the sum, and it will move to the R0. So like that, the indirection point is very helpful to efficiently execute the program task and make it faster also. So let's go for last small topic here. These are called addition modes, where upcoming session definitely explain the addressing modes clearly. So here addition modes, there are two operand is there. Two modes are important, that is auto increment, another one is auto decrement. How do you represent the auto increment? If you want to represent the auto increment, you have to use the indirect operation, that's Ri, open process close plus, that is a way of incrementing mode. The effective address of the operand is the content of the register specified in the instruction. After accessing the operand, the contents of the register is automatic increment to point to the next item. That is the advantage of auto increment. So keep in mind that when I want to give the auto increment mode and execute some program task, what will happen? Once the instructions executed successfully, then the auto increment value will be moved, that means increased. For example, you have a register value 399. After execute after runtime or compiling and execute the instruction successfully, after applying the additional auto increment mode, the 399 become 400 like that. If you repeat again, the value comes to the 401. Okay, then we come to the auto decrement mode. This is quite opposite of auto increment mode, where it is denoted by minus RIF, that is representing the decrement mode, where open brackets. Here the contents of the register specified in the instruction are first automatic decremented. After that, used as the effective address of the operand. So here, for example, assume that the register value is 399. So whenever program task is execute, by default the 399 become to 398 because we are applying the auto decrement. Then it will execute the task and give the result. So these are the very important things you have to remember about the conditional flags as well as the interaction pointers or class addition modes. Okay. Thank you for watching this video. Please subscribe and press bell icon for more updates. Please share with social media and connect with the social media like Facebook, Twitter, LinkedIn. Thank you.